myself, Gautam Sudhakar, assistant professor and head of the Department of Chemistry, KP Arts, SN Science, and KPC Commerce College. In previous lecture, we have seen what is a nucleophile, what is electrophile, what are different types of reactions, as well as SN2 mechanism. SN2 mechanism, as well as the its energy profile diagram. Now, in this lecture, we want to discuss SN1 mechanism. What is a SN1? What is a SN1? So before that, just I want to share my screen. What is a SN1? SN1 means substitution nucleophilic unimolecular. Substitution nucleophilic unimolecular reactions. Now we want to discuss mechanism. Generally, tertiary alkyl halide. Which one? Generally, tertiary alkyl halide undergo reactions via SN1 mechanism. This one is the way R1, R2, and R3 are alkyl groups. When R1, R2, and R3 are alkyl groups. It means that when this carbon is connected to 3 carbon, that carbon are called as a tertiary. Generally, so SN1 mechanism, generally tertiary alkyl halide undergo faster reactions. Secondary alkyl halide also undergo these reactions, but rate of reactions it is to be smaller. Rate of reactions it is to be smaller in case of what we can say SN1. Now SN1 involves two-step mechanism. SN2, if you see the SN2 which is here, SN2 involve single-step mechanism SN2. That is the attack of a nucleophile is to take place from back side and leaving group depart from front side. Now that is a SN2, but SN1 involve two-step mechanism. Step first, this is step first. What is that a step first? That is the formation of a carbocation. So what happened here? The bond between carbon and chlorine. यहाँ पे जो कार्बन और क्लोरीन का जो बॉन्ड है, now that bond is to be broken down. And as you know, which is more electronegative, carbon or chlorine? I think so. You can remember, chlorine is more electronegative or carbon. So chlorine is a much more electronegative than the carbon. यहाँ पे जो क्लोरीन है इसकी इलेक्ट्रोनेगेटिविटी जो है कार्बन से ज्यादा है. So what happened here? Now the bond between carbon and chlorine broken down in a such way that chlorine acquires a negative charge and carbon acquires a positive charge. So this is the step first formation of carbocation. So this यहाँ पे जो भी कार्बन जो है, now that carbon just acquires a positive charge. So यहाँ पे जो भी कार्बन है, now that carbon acquires a positive charge. So यहाँ पे जो भी कार्बन है, so this is nothing but a carbocation. And carbocation, before that you must know this is a step first, is a slow step. ये जो पहली step है, यह है slow step, and these are also called as a RDS. RDS means rate determining step. So according to chemical kinetics, what is the rate law? Anybody? Rate law? The rate of reactions is directly proportional to the concentration of a reactant. So rate is directly proportional to the concentration of a reactant. यहाँ पे जो है तो आपको पता होना से यहाँ पे रिएक्टेंट क्या है? सो रेट ऑफ रिएक्शन इज डायरेक्टली प्रोपोर्शनल टू द कंसंट्रेशन ऑफ रिएक्टेंट ओनली रिएक्टेंट। यहाँ पे जो है ओनली वन रिएक्टेंट है, सो ये ओनली वन रिएक्टेंट है। तो रेट ऑफ रिएक्शंस यहाँ पे हम अगर प्रोपोर्शनलिटी साइन रिमूव करते हैं तो हमको यहाँ पे क्या लेना पड़ेगा? रेट इज इक्वल टू स्मॉल के इज अ रेट कांस्टेंट, स्मॉल के नॉट अ कैपिटल के इज इक्विलिब्रियम कांस्टेंट, सो स्मॉल के and into concentration of a alkyl halide, or that is the concentration of a substrate. So rate of reactions is depend upon only one molecule. यहाँ पे जो भी rate of reactions है, so rate of reactions in case of SN1 is depend upon concentration of substrate only, that is only one molecule. That's why we can say this is nothing but a substitution nucleophilic unimolecular. Why these are called as unimolecular? Because the rate of reactions depend upon only one molecule. Now, as you know, the carbocation which is formed here, मैंने पहले लेक्चर में आपको बताया, what is the hybridization of this carbocation? So carbocation having a sp3 hybridization. बराबर है क्या? कार्बोकैटायन का हाइब्रिडाइजेशन sp2 होता है, sp3 होता है। तो कार्बोकैटायन which is formed here, now that is to be sp2 hybridized. So this is a sp2 hybridized and its geometry is a trigonal planar और यहाँ पे जो भी बॉन्ड एंगल है now that is nothing but 120. अगर ये ट्राइगोनल प्लेनर है तो अटैक ऑफ अ न्यूक्लियोफाइल is to take place from back side as well as the front side. तो यहाँ पे both possibilities है। So यहाँ पे क्लोरीन जो है C है। So the attack of a nucleophile is to be takes place from back side as well as from front side. ये जो न्यूक्लियोफाइल जो है इसका जो अटैक जो है now it is attack is to be takes place from this is a back side. Attack is to be takes place from back side as well as attack is to be takes place from a front side. So both there are two possibilities. अटैक यहाँ पे जो न्यूक्लियोफाइल जो है उसका जो अटैक जो है एक तो बैक साइड भी हो सकता है और फ्रंट साइड भी हो सकता है. So attack of a nucleophile is to take place from front side as well as from a back side. So here you will get the nucleophile attack from either side of a carbocation, either side of a carbocation. It means back side or it may be front side. Hence, if the attack of a nucleophile is to takes place from a back side, अगर nucleophile का attack इधर back side से होता है, so here you will get an inversion in concentration. So this is a inversion. और अगर न्यूक्लियोफाइल का अटैक अगर फ्रंट साइड से होता है, तो here you will get a retention in configuration. समझो ये अगर आपको यह R कॉन्फ़िगरेशन मिला है, ये अगर R है, इसका कॉन्फ़िगरेशन अगर R है, तो डेफिनेटली इसका कॉन्फ़िगरेशन S होगा. So it means that if a mixture of both isomer, अगर R भी है यहाँ पे और S भी है, so we can say now that is nothing but it is a racemization, or in case of SN1 mechanism you will get a racemization, or here you will get a racemic mixture. Why you will get a racemic mixture? Because the step first involves formation of carbocation, and carbocation which is formed here, now that is a sp3 hybridized having a trigonal planar geometry. As it have a trigonal planar geometry, attack of a nucleophile is to take place from back side as well as from a front side. So here you will get a racemization. So this is nothing but a SN1 mechanism, and as already I have told you, these are called as unimolecular. Why these are called as unimolecular? Because rate of reactions will depend upon only concentration of substrate, and it is not depending upon concentration of a nucleophile also. So it means that what we can say that is it is also important. Now that is nothing but a rate determining state. So substrate का जो रोल है यहाँ पे सबसे important है. Now we want to discuss that is a reactive intermediate SN1 and E1. So just you can remember, अगर यहाँ पे ये जो ग्रुप है, अगर ये न्यूक्लियोफाइल अगर काम करता है तो here you get a nucleophilic substitution reaction. समझो हमने यहाँ पे KOH किया, जस्ट यू कैन कंपेयर, हमने यहाँ पे क्या किया है, KOH लिया, तो KOH जो है KOH, तो OH माइनस here you will get, so OH माइनस का जो रोल है, so now that act as a nucleophile as well as a base. If OH minus act as a nucleophile, then this is a nucleophilic substitution. And if OH minus, attack of OH minus ion is to take place, or if that act as a base, then it undergo elimination reaction. So that is to be important. So you can, this is not part of our syllabus, but just you can remember, if that act as a nucleophile, then nucleophilic substitution reactions is to be takes place. Now we want to discuss about the, what we can say, energy profile diagram for SN1 reactions. SN1 reactions, तो यहाँ पे जो भी reaction है, so this is nothing but just we want to discuss now energy profile diagram for SN1. So this is the initial state. Now that is nothing but this is the initial state where the formation of a carbocation. तो पहली जो step है यहाँ पे, so this is nothing but this is alkyl halide. I can't write each and everything, but just you can remember this is a tertiary alkyl halide. ये जो है यहाँ पे tertiary alkyl halide है, और ये जो बॉन्ड है X है, ये जो बॉन्ड है यहाँ पे जो बॉन्ड है, तो ये बॉन्ड जो है यहाँ पे ब्रेक होता है, so there is a formation of a carbocation. यहाँ पे जो है कार्बोकैटायन फॉर्म होता है, ये जो पहली ट्रांजिशन स्टेट है, now that transition state involves formation of a carbocation. Now that carbocation having the highest state maximum, and if the attack of a nucleophile, यहाँ पे जो है, so attack of a nucleophile is takes place from back side as well as the front side. See, this is a carbocation, और ये जो B है, so that is nothing but a nucleophile. So attack of a nucleophile is to takes place, and this another second transition state involve again attack of a bond. That is the attack of a nucleophile. And so again its transition energy goes on increasing, and this is a second maxima which is to be there. So this is the second maxima, and that's energy goes on decreasing, and it gets converted into what we can say product. यहाँ पे जो है, suppose this is A is the substrate and B is a nucleophile. यहाँ पे जो है कार्बोकैटायन फॉर्म होता है और B का अटैक होता है, again you will get a second intermediate. This is the second maxima, and it gets converted into product. So we want to discuss some. This is the energy. So what is it involves two energy of activation. So this is the intermediate. जो भी intermediate है और जो reactor है, इसके बीच में का जो भी energy difference है, now that is nothing but that is the energy of activation. Now that is nothing but delta G. This is the energy of activation. It have a two maxima, so it have a two energy of activations. यहाँ पे दो energy of activations है, and this is the energy difference between reactant and product. So that is nothing but enthalpy change. अगर आप thermodynamics के बारे में अगर आपको पता होगा तो that is nothing but it involves enthalpy change, or that is a delta H. कुछ जगह पे डेल्टा G0 भी लिखते हैं और डेल्टा H भी लिखते हैं. So we are not a student of, means that I am not a student of physical chemistry. So just you can remember that is the difference between these two. Now that is nothing but enthalpy change. And here you will get this is the energy profile diagram of what we can say, that is SN1. It is to be given here. Now this is the energy profile diagram. See here, this is the energy profile diagram for SN2 reactions. Sorry. This is a energy profile diagram of SN1. So actually I am confusing between SN1 and SN2, but just you can remember this is a SN1, जहाँ पे जो भी कार्बोकैटायन फॉर्म होता है, तो कार्बोकैटायन जो भी फॉर्म होता है, तो नाउ दैट इज नथिंग बट SN1. यहाँ पे ये है स्टार्टिंग है, यहाँ पे ये जो बॉन्ड है ये ब्रेक होता है, बॉन्ड ब्रेक हो जाने के बाद में यहाँ पे कार्बोकैटायन फॉर्म होता है. अटैक ऑफ अ न्यूक्लियोफाइल इज टू टेक प्लेस फ्रॉम बैक साइड एज वेल एज फ्रॉम फ्रंट साइड, एंड हियर यू विल गेट दीस आर टू प्रोडक्ट. ये पहला प्रोडक्ट है और यहाँ पे सो हियर यू विल गेट दीस आर टू प्रोडक्ट, एंड ये जो डिफरेंस है इसमें का रिएक्टेंट और प्रोडक्ट का, सो दैट इज नथिंग बट what we can say now, that is nothing but enthalpy change. So this is the energy profile diagram for a SN1 mechanism. So we want to stop here. In next lecture, we want to discuss about the SNI, substitution nucleophilic internal mechanism. Okay, so we want to